Yes, fusion power is fundamentally safe. The physics and the reactions of the fusion system itself means you don't have runaways. And so we've talked about some of the human factors around power plants and power systems and industrial scale systems. And that's something that we build into the design of these from today. We look at how these systems might fail. And in fact, some of the analysis we do is we did this analysis for the Nuclear Regulatory Commission over the last few years, looking at how do you regulate fusion power? As we're building the first fusion power plant, we need to make sure we're regulated safely. And so we spent a lot of time doing the technical case and the political case in the United States of how to regulate fusion. And so the analysis we did is assume you have a fusion power plant that's operating. And then at any one time, a meteor strikes it. The whole thing is vaporized. What is the impact of that? So this is worse than you could ever imagine an actual physical scenario, but let's start there. And the answer is you don't need to evacuate the populace nearby the fusion power plant. And one of the keys I think that I come to when I think about this is the fuel. In that in a fusion generator, you are continuously feeding in this hydrogen, these deuterium fuels. And at any one time in a helion fusion system, and most fusion systems, you have 1 second of fuel in that system. And so what that means is if you stop putting fuel into that system, fusion just stops. But what it also means is that if something really catastrophic happened and for whatever reason, you have all of that fuel that's not in the system. And fusion is so hard to make happen. You hit it with a meteor, you do anything in that nature, and fusion doesn't happen. That hydrogen, that heavy water, that deuterium just goes back into the environment safely and cleanly without issue. And so that's the fundamental safety mechanism of fusion. And you can compare that with other types of power plants, oil or a coal power plant. You might have a large pile of coal that then catches fire and burns. And it's not catastrophic, but you have a large coal fire for a long time, releasing toxic fumes that you may have to deal with. And in nuclear power and a fission power plant, you may have several years of fuel sitting in the core. And in that case, if something bad happened, you have all that potential energy for things to happen. But in fusion, you have literally 1 second of fuel at any time in the system. And having a tank of deuterium, which we have around all the time, can't do fusion by itself. It needs that complex system.